Over the past few years, SpaceX has produced more rockets than all the other space agencies of the world combined over a comparable period. But the most striking fact is not that. The largest rocket factory on the planet does not produce the key part without which not a single one of its rockets will lift into the air. This part is transported by trucks across half the country and installed last of all. How is a factory arranged whose goal is to produce a spacecraft every day? And what is this part that it does not make itself? Everything begins not with engines and not with assembly towers. Everything begins with a coil of stainless steel, the same material from which kitchen sinks are stamped. In a few weeks, this coil will turn into a Starship, a rocket that, together with its booster, exceeds the height of the Statue of Liberty. The place where this happens is Star Factory in Texas. The area under one roof is 13 football fields. One goal, 365 ships a year, steel that grows stronger in the cold. In 2019, the choice of material for Starship was explained with two figures. A kilogram of the carbon fiber composite from which the ship was originally planned to be built cost about $135. A kilogram of stainless steel, $3. The project was redone, but price is only half the story. The first prototypes were welded from grade 301 steel, then they switched to 304. Today, coils of an alloy that exists nowhere else in the world move through the shop. SpaceX developed it in-house, and the exact composition has still not been disclosed. The main property of this steel is that it behaves non-standardly. The colder it gets, the stronger it becomes. For a rocket, this is fundamental. At the moment of launch, the tanks are filled with fuel cooled to almost minus 180 degrees. It is precisely under maximum load that the metal reaches peak strength. Upon re-entry into the atmosphere, the same hull withstands heat that would have long since melted the aluminium of ordinary rockets. To this is added a third requirement. The factory stands by the sea, and the finished ships will spend years in salty air. That means no rust. At the same time, the alloy must bend and weld easily, otherwise the factory would not be able to handle it. A seam in one revolution, a steel strip 80 wide and 4 mm thick, enters an automatic machine. A blade cuts the sheet, the edges are brought together, a flash of welding, and before us is no longer a sheet, but a ring 9 meters in diameter, wider than a 3-lane road. Rings are stacked in 3s or 5s, then a robotic arm travels around the joint and welds it in one continuous motion. One revolution, one finished seam. Before, everything looked different. The first starships were welded by hand, from top to bottom. People in masks hung on scaffolding for weeks, and the smell of burnt metal stood in the shop. The smell has remained. The scaffolding is almost gone. The large seams have been handed over to machines. People work where precision and experience are needed. Complex assemblies, non-standard spots a robot cannot reach. A welder here no longer builds a rocket from start to finish. He brings it to perfection. Water against steel. Where there are no straight lines, hydroforming comes into play. A sheet is laid on a die and liquid is fed from above under a pressure of almost 2,500 atmospheres, twice as much as at the bottom of the Mariana Trench. The steel obediently takes shape, like foil. A person does not touch the metal at this moment. All operations are controlled from a console. This is how the domes of the fuel tanks and the curved panels of the nose cone are formed. The finished sections need to be moved through the factory, but there is no conveyor here. The end of the conveyor. For more than 100 years, complex machines have been assembled according to Henry Ford's scheme. In 1913, his factory launched the first conveyor, and chassis assembly time was cut from 12.5 hours to 93 minutes. Since then, the belt has crawled through every major production shop: cars, refrigerators, aeroplanes. The scheme is so familiar that it is perceived as a law of nature. SpaceX decided that it is not a law. The biography of the leader played a role here. He is the only person who simultaneously runs both a car factory and a rocket factory. Tesla's engineers publicly presented an alternative to the conveyor in 2023, a method called unboxed. The car is mentally divided into large blocks. They are assembled in parallel at different stations and in the end joined into a single whole. At the rocket factory, the same principle is described differently: linear adjacent flow. The essence is the same. One task remains: the sections weigh as much as a bar. pass and they still need to be moved. The solution? Right above the workers' heads, roads under the ceiling. The entire shop is covered by a grid of steel beams, at first glance the load-bearing structures of the roof. In fact, a transport network. Overhead cranes travel along the beams. Each one hooks onto a section, lifts it vertically and carries it through the air to the next station. Below, the work does not stop. At the stations, the sections are lowered onto rotating stands. The part slowly turns like a potter's wheel and the work itself drives up to the hands of the craftsman. This is what Star Factory looks like from the inside. Dozens of pieces of different ships simultaneously moving, rotating, becoming covered with parts. And all of this under one roof. A rocket from parcels. For contrast, how assembly is organized at NASA. Their new super heavy rocket SLS is created literally from all over the planet. One block in California, another in the state of Utah, a third in Louisiana. Part of a ship for lunar flights is manufactured in Europe. Then all of this is loaded onto barges, trailers, transport planes and taken to Florida. Only there is the rocket assembled in stages, floor by floor. According to calculations by NASA auditors in 2021, one launch under this scheme costs more than $4 billion. At Star Factory, this entire route, thousands of kilometers, barges and planes, is replaced by a crane under the ceiling. Top, middle, bottom. Of the two stages of Starship, only one is needed in mass quantity, and it is not the booster. The super heavy booster works as a shuttle. It pushed the ship towards space, returned to the launch pad, and is ready for the next launch within minutes. One or two such machines are needed per launch table, but ships, a whole fleet, one in orbit, another near the moon, a third heading to Mars for months. A returned ship waits weeks for a new load. For launches to happen every day, there must be many ships in work, and all at different stages of the route. The ship's nose cone is dressed in heat protection click by click. First, the surface is dotted with small metal studs, anchors for the tiles. Then a black cloth is laid down, a backup shield in case a tile is lost in flight. On top, white foam filling the gaps, and only then hexagonal tiles. SpaceX produces them right at the factory in a shop called the bakery. The technology is close to tile manufacturing. Mold, kiln, glaze. The automatic line produces more than 1,000 tiles a day, with a target of 7,000. The hexagonal shape was not chosen for aesthetics. With square tiles, the seams form long straight lines, and hot plasma during descent can cut a path along such a seam. Hexagons have no straight-through paths. Plasma has nowhere to build up speed. Special openings are cut in the cargo bay, a long slot for releasing Starlink satellites. There are already more than 8,000 of them in orbit, which is more than half of all humanity's operating satellites as of 2025, and two round docking hatches. Through them, two starships will be able to dock right in orbit and transfer fuel, the way two cars share gasoline on the highway. No production rocket has ever been able to do this before. Meeting place. All the assembled sections come together at one point, the Gigabay, a tower 116 meters tall and more than 1,300,000 cubic meters in volume, 24 stations for ships and boosters. 12 fully equipped rockets can be assembled here simultaneously. The company began building a second such complex in Florida in 2025. A crane lifts the sections, the top connects with the middle and the bottom. Crews on different tiers pull fuel lines, run wiring, install the last tiles. From the outside the ship looks finished, but under the tail skirt it is empty. The last part, the residents of the Texas town of McGregor know this sound with their eyes closed. SpaceX has been testing engines here since 2003. A roar for kilometers, a trembling in the windows. It is here that what Star Factory does not produce is brought, Raptor engines. They are assembled on the other end of the country in Hawthorne, California, the same place where the Falcon 9 rocket was born. Each Raptor develops more than 200 tons of thrust with dimensions roughly the size of a passenger car. Fuel, methane and liquid oxygen. Methane was chosen with an eye to the future. It can be produced right on Mars from local carbon dioxide and ice in order to refuel ships for the return trip. The finished engine is transported by truck to McGregor, placed on a stand and fired at full power. All problems must show up here on the ground. Only after the static fire tests does the engine go to its ship. First, the ship without engines undergoes a stress test. It is loaded with pressure as an aerial launch. Then part of the engines are mounted and a ground static fire test is conducted. The lines, electronics and automation are checked. Only after all of this does the machine return to the Gigabay, receive a full set of engines and a new status, ready for flight. Today, Star Factory builds ships faster than they manage to launch them. Finished machines stand in the Gigabay and wait their turn. But this will not last long. As soon as Starship takes on real commercial load, deploying next-generation satellites, lunar missions, orbital operations, the pace will break loose at full force. For reference, the Falcon family carried out 134 launches in 2024. That is more often than once every 3 days. Starship must fly no less often. And further ahead, orbital data centers, lunar expeditions, where an entire chain of launches and refuelings is needed for a single landing ship, and Mars, where ships will depart not one at a time, but in fleets, all of this simultaneously. That means the world will need more rockets than in the entire previous history of spaceflight. By the way, the settlement around the factory officially received city status in May 2025. Name Starbase, Star Base. And every rocket of this city begins the same way, with a coil of steel at the low gates of the factory on the shore of the Gulf of Mexico. If you are interested in how the larger scale projects and technologies of our time are built, subscribe to the channel and give it a like. Write in the comments what you think about this episode. And right now on the screen our previous episodes, which are already waiting for you.